Question number 1. Calculate the wavelength of light emitted when an electron moves from fourth energy level to the second energy level of hydrogen atom. So electron at a fourth energy level or para second energy level or leke ahise boli koise hydrogen atom eta. So jitu electromagnetic radiation yat energy jiman asile second energy level hole amte electron to energy komi jabo mane energy to bol ko that energy will come out as electromagnetic radiation or light. So what is the wavelength of this electromagnetic radiation? That is what you are asked to find. Now for that, let us first calculate the energies of the respective levels. So fourth energy level or second energy level hole koise fourth energy level of electron to energy kiman minus 21.8 into 10 to the power minus 19 by 4 square joule. This is energy in terms of joule. Second energy level hole ahile second energy level or energy to kiman minus 21.8 into 10 to the power minus 19 by 2 square. So this is n square. Fourth energy level of n equal to 4. Second energy level of n equal to 2. So E4 and E2, these are the two energies that we will have in this case. Now fourth energy level of electron to energy besi, second energy level of electron to energy com, kiman energy komi gol to ulia pole hole. So if del E jodi electron to del E energy komi gol, then del E will be E4 minus E2. So what is E4? So del E will be E4 minus E2. What is del E? Del E is E4 is minus 21.8 into 10 to the power minus 19 by 4 square, and E2 is this minus E2 is minus 21.8 into 10 to the power minus 19 by 2 square. So it will be minus 21.8 into 10 to the power minus 19 1 by 4 square minus 1 by 2 square, and on solving we get the result as 4.08 into 10 to the power minus 19 joule. So this is the iman khini energy electron to lose koribo jeta electron to fourth energy level or second energy level hole ahibo. So this amount of energy is equal to what wavelength of light? So this del E is equal to h nu, and del E equals to hc by lambda, and you are asked to find out the wavelength, and that means lambda equals to hc by del E. So del E you have, h you have, c you have. Please find the wavelength. In question number 2, it is given that the ionization energy of an excited state of hydrogen is plus 0.85 electron volt. So I have an excited state of hydrogen where the ionization energy is plus 0.85 electron volts. So if the electron returns from that excited state to the ground state, then how much energy is lost? So electron to eta excited state ase, excited state to thakute electron or ionization energy plus 0.85 electron volt, tete hole electron to jodi ground state ghuri ahe tete electron to energy kiman hobo. Now so if the ionization energy for the nth state is plus 0.85 electron volt, then the energy of the electron in the nth state will be minus 0.85 electron volt. So minus 0.85 electron volt will be the energy of the electron in the nth shell. Now if En is the energy and this is the ground state energy, then delta E will be En minus ground state energy, that is minus 0.85 minus 13.6 electron volt. So this will come out as 12.75 electron volt. That means this 12.75 electron volt energy is lost if the electron returns to the ground state from a state where the ionization energy is plus 0.85 electron volt. Okay, so this is the way of doing the question. Now let us see the probabilities of which an electron can return to the ground state. So আমি কৈছিলো যে ইলেক্ট্রন টু if n equals to 1 is the ground state for hydrogen atom, n equals to 2, 3, 4, 5, all of these are the excited states for hydrogen atom. Now if 2 is the excited state, 2 can 2 পৰা ডাইৰেক্ট 1 ওলাই আহিব পাৰে, বেলেগ probability নাই। 3 যদি আছে ইলেক্ট্ৰনটা, ধৰি লওঁ ইলেক্ট্ৰনটা 3 আছে, 3 পৰা 2 লৈ আহিব পাৰে, 2 পৰা 1 লৈ আহিব পাৰে, নাইবা ডাইৰেক্ট 3 পৰা 1 লৈ আহিব পাৰে। এগেইন 4 যদি আছে 4 পৰা 3 লৈ আহিব পাৰে, 3 পৰা 2 লৈ আহিব পাৰে, 2 পৰা 1 লৈ আহিব পাৰে। Okay, that means there is a probability that 2 পৰা 1 লৈ আহিছে, 3 পৰা 1 লৈ আহিছে, 4 পৰা 1 লৈ আহিছে বা 5 পৰা 1 লৈ আহিছে। That means n2 to n1 equals to 1. That means n2, that means 2, 3, 4, 5. এইবোৰৰ পৰা n1, that means n equals to 1 লৈ আহিছে। n equals to বেলেগ কিবা এটাৰ পৰা n equals to 1 লৈ আহিছে। যেতিয়া আমি n equals to বেলেগ কিবা এটাৰ পৰা n equals to 1 লৈ অহা লাইনবোৰে অকল কনসিডাৰ কৰিম, সেইবোৰৰ কাৰণে মই এটা ফটোগ্ৰাফিক প্লেটত কিছুমান লাইন পাম যে। সো এইবোৰ কেতিয়া হৈছে, যেতিয়া হায়াৰ ষ্টেটছৰ পৰা 1 লৈ আহিছে, হায়াৰ ষ্টেটছৰ পৰা যেতিয়া 1 লৈ আহিছে তেতিয়া আমি এইবোৰ লাইন পাইছো। Okay, so these lines that are obtained when an electron returns from a higher energy state to n equals to 1 are called Balmer lines. Not Balmer lines, they are called Lyman lines. They are called Lyman lines. Okay, so Lyman lines or ki hobo n2 equals to higher state, ইয়াৰ পৰা আহিব n1 equals to 1 অৰলে আহিব। সো এইবোৰৰ কাৰণে আমি যেটো সিৰিজ অফ লাইনস পাম, 2 পৰা 1 অৰলে আহিলে এটা লাইন পালো, 3 পৰা 1 অৰলে আহিলে এটা লাইন পালো, 4 পৰা 1 অৰলে আহিলে এটা লাইন পালো। So all these lines are obtained when an electron returns to n equals to 1. So these lines are called Lyman lines. Okay, now so these are called Lyman lines. So the energy of an electron in a particular state En equals to minus 13.6 by n squared. Here the electron returns from the nth state to first state, so the E1 is minus 13.6. That means for Lyman lines, this is electron volt, this is electron volt. For Lyman lines, delta E will be equal to En minus E1. This is the condition for Lyman line, which is seen when electron returns from a higher energy state to the first state, and we get a series of lines called the Lyman lines, for which this is the expression for delta E. We can also have another set of lines in which the electrons, rather than coming to the n equals to 1 state, electron to n equals to 1 state or ohar jagah jodi n equals to 2 state ole ahe, higher energy states or pora jodi 2 states ole ahe, 3 pa 2 le ahile, 4 pa 2 le ahile, 5 pa 2 le ahile, so jeti ami 1 or jagah 2 consider koru, lower level to 2 consider koru, then the series of lines that we get are called Balmer series. So these lines are called Balmer series. Similarly, if electrons, instead of coming to 2 state, they come from n equals to 3 state, 5 over 3 le ahile, 4 over 3 le ahile, 6 over 3 le ahile, 7 over 3 le ahile, in that case for Balmer series the n2 to n1 equals to 2, higher energy states hoba n equals to 2 le ahile, jeti ami Balmer lines pam, jodi 2 jagah 3 le ahe, then we get P-fund lines. So for P-fund lines, n2 to n1 equals to 3. Okay, so this is for Balmer lines, is for not P-fund, it is Paschen, not P-fund, it is Paschen line. So Lyman lines for higher to n equals to 1, Balmer from higher to n equals to 2, Paschen from higher to n equals to 3. This is Paschen. Now, what will be the energy lost when we consider Balmer lines? So delta E will be equal to minus 21.8 into 10 to the power minus 19 by n square for the nth level minus 21.8 into 10 to the power minus 19 by 2 square. That is for Balmer series. The lower level is 2, n2 is 2. Okay, so this we get as minus 21.8 into 10 to the power minus 19 1 by n square minus 1 by 2 square. Okay, so similarly, if we consider this is for Balmer series, so higher level is n, lower level is 2. Similarly, if we consider Paschen series, the delta E will be, this is minus 21.8 into 10 to the power minus 19 1 by n square minus 1 by 3 square, 1 by n square minus 1 by 3 square. Okay, now instead of coming to any higher level to n equals to 3, the electron can come from higher level to n equals to 4. In that case, we get something called bracket series. This is called bracket series of lines. Okay, that means if we generalize the line spectrum of hydrogen, which I told you in the earlier class, if I try to generalize the line spectrum of hydrogen, in all cases the general expression for energy lost when an electron comes from a higher energy level to a lower energy level, delta E will be minus 21.8 into 10 to the power minus 19 1 by n1 square minus 1 by n2 square. So this is the general expression. So where n1 is greater than n2, higher level or pura lower level ole aise, ekarone ami higher minus lower korisu. Okay, so where n1 equals to n2. For Lyman series, n2 equals to 1. For Balmer series, n2 equals to 2, and so on. In this way, we can easily calculate the energy difference for a line in the line spectrum of
hydrogen atom. The energy of the nth shell of the hydrogen atom in terms of electron volts is given as En equals to minus 13.6 by n squared electron volt. So this is in terms of electron volt. Now, so if I try to calculate the energies of the different levels for k shell n equals to 1 minus 13.6, n equals to 2 minus 3.4, n equals to 3 minus 1.5, n equals to 4 minus 0.85, and n equals to 5 minus 0.544 electron volt. So these are the successive energies of the energy levels. So if I go from n equals to 1 to n equals to 5, the energy will increase. Energy to my n equals to 1 or upole goi thakile bahi goi thakibo energy. Try to calculate the energy difference between the higher energy level and lower energy level. Successive higher energy level aru lower energy level or majot jodi moi energy difference bu uliabo chau, that means successive mane ki itur pichot itu 1 or 2 major energy difference to kiman, 2 or 3 major energy difference to kiman, 3 or 4 major energy difference to kiman, 4 or 5 major energy difference to kiman. So if I try to calculate the successive energy difference in the energy levels, then between 2 and 1 the energy difference is 10.2 electron volt. So how did I calculate this energy difference? So upper minus lower, minus 3.4 minus 13.6. okay, so upper minus lower korisu, tetia moi paisu 10.2 electron volt. So this is the difference between n equals to 1 and n equals to 2. Similarly, 2 or 3 major difference to 1.9 electron volt, 3 or 4 major to 0.65, aru 4 or 5 major to 0.306. Now that means a energy difference bur jibur ase, energy difference bur moi jodi tolor level or pora upor level ole jao, tetia energy level or major energy difference bur komi goi ase. So there is a decrease in the difference in the energies of successive energy levels. Successive energy levels or jitu energy difference etu komi goi ahi ase.
So as we already discussed, the energy of the nth cell is minus 13.6 by n square electron volt. So what we did is we calculated the energies of all the levels of the first 5 levels. Prothom 5ta level energy ami calculate korilu. Tar pisot ami we calculated the energy difference between the levels. Okay, so higher level minus lower level jodi koru ami level gitar major energy difference to ami gon pai jam. So what we did is we calculated the energy difference between the levels. So what we saw was, as we proceed from lower levels to the higher levels, the energy difference between the levels shrinks. Okay, so which is not particularly observed or taught in schools. School of nokoy generally to kotha je level bor mazot energy difference to komi je level bor shrink hoi hoy je kintu ehomoyat level bor ekdom usor gusi jaboge still energy difference to zero hoi na jay. Okay, now so if I if del E1 is the difference between the level energy difference between level 1 and 2, del E2 for level 2 and 3, del E3 for level 3 and 4, and del E4 for level 4 and 5. So these are the energy levels. Then the relation between del E4, del E3, del E2, del E1 is del E4 less than del E3 less than del E2 less than del E1. So this question was there in JEE main 2014, 15, 17. 3 years. Same question. 3 consecutive exams. So not consecutive. 3 JEE mains. Same question. 3 times. Okay, so this question is very, very important for JEE main. Okay. So the difference of energy. So in terms of joule, if we represent En, that means energy of the nth cell in terms of n square. So the unit being joule, the expression that we get is En equals to minus 21.8 into 10 to the power minus 18 by n square joule. Now, so if the electron moves from n2 to n1, electron to jodi n2 pora n1 ole jay, where n2 is greater than n1. So if electron moves from n2 to n1, then wavelength is emitted, the light emit ইয়াত এনার্জি বেশি ইয়াত এনার্জি কম, দ্যাট মিন্স ইয়াৰ পৰা ইয়ালে আহোঁতে এনার্জি কমি গ'ল, এনার্জিখিনি গ'ল ক'ত, এনার্জিখিনি এজ ইলেক্ট্রোম্যাগনেটিক রেডিয়েশন ওলাই গুচি গ'ল। ইলেক্ট্রোম্যাগনেটিক রেডিয়েশনৰ এটা ওয়েভলেংথ থাকে। সো হোৱাট ইজ দ্য ওয়েভলেংথ অফ দ্য ইলেক্ট্রোম্যাগনেটিক রেডিয়েশন? নাও for calculating that, what we do is we first find out the energy difference between the two levels. So delta E that we calculate, we get as 21.8 into 10 to the power minus 18 into 1 by n1 square minus 1 by n2 square joule. This is the difference in energy between the two levels in joule units. Okay, so this much of energy is emitted in the form of electromagnetic radiation. That means the energy of any electromagnetic radiation that is emitted, this energy corresponds to this wavelength lambda. So what is this lambda then? So if we try to find out the value of lambda, so this delta E, this is equal to h nu equals to 21.8 into 10 to the power minus 18 into 1 by n1 square minus 1 by n2 square. Okay, so that means hc by lambda equals to this much. Now, so we know the value of h, we know the value of c. So this is a constant. We can divide this constant by h and by c, and if we calculate 1 by lambda, we get it as 109677 1 by n1 square minus 1 by n2 square. So 1 by lambda equals to 109677 into 1 by n1 square minus 1 by n2 square, where n2 is greater than n1, higher level, lower level. So this is the wave. So this is with respect to the wavelength. So 1 by lambda is the wave number. So what we are actually getting is we are getting the wave number of the wave which is emitted when the electron comes from n2 to n1. So this is the equation that tells us about the wave number. So when we calculate the wave number, we get 1 by lambda equals to 109677 1 by n1 square minus 1 by n2 square, where n2 is greater than n1, that means n2 is the higher energy level, n1 is the lower energy level. Jodi electron to n2 পৰা n1 লৈ আহে তেতিয়া কিমান wavelength emit হ'ব 1 by lambda, and delta E is the energy difference between the two levels, মানে electromagnetic radiation যেটো ওলাই যাব তাৰ energy কিমান হ'ব. So delta E, this much of energy will be carried by the electromagnetic radiation. So delta E is 21.8 into 10 to the power minus 18 into 1 by n1 square minus 1 by n2 square joule. So if we see these two, this is in terms of centimeter inverse wave number and this is in terms of joule, that is energy. Now this 109677 is a constant, this is also a constant. Okay, so 109677 and 21.8 into 10 to the power minus 18, so these are called Rydberg constant. A constant gita Rydberg constant boli koa. So this is the Rydberg constant in terms of centimeter inverse, and this is the Rydberg constant in terms of joule. So Rydberg constant RH, so Rydberg constant RH is 109677 centimeter inverse, and RH is 21.8 into 10 to the power minus 18 joule. So we get two Rydberg constants. দুইটা একে হয়, খালি ইউনিট কিটা বেলেগ কৰি দিছো. যদি মই সেন্টিমিটাৰ ইনভার্স টু জুললে কনভার্ট কৰি দিও মই ইমানটো পাম. যদি মই this much of joule if I convert to centimeter inverse, I get this much 109677. So what is the Rydberg constant? Rydberg constant মানে কি? So Rydberg constant is the amount of energy released when electron comes from infinity to 1. Infinity পৰা 1 লৈ আহিলে যিমানটো energy release হ'ব, that is Rydberg constant. Okay, so this Rydberg constant will be useful for us for solving a number of problems. Now, so this is the Rydberg constant. So let us see delta E equals to RH in terms of joule 1 by n1 square minus 1 by n2 square. So RH 1 by n1 square minus 1 by n2 square. So delta E equals to RH when n1 equals to 1 and n2 equals to infinity. যেতিয়া ইলেক্ট্ৰন টু ইনফিনিটিৰ পৰা 1 লৈ আহিব তেতিয়া হলে কিমান এনাৰ্জি ৰিলিজ হ'ব? RH amount of energy will be released. So this is the physical significance of the Rydberg constant, which is important. Okay, so delta E equals to Rydberg constant when n1 equals to 1 and n2 equals to infinity. So delta E equals to RH. So this question was asked in JEE main 2015. So 2015 or JEE main on a question to kudisile. So when an electron moves from infinity to the first energy level, what is the amount of energy released? So the amount of energy released is Rydberg constant RH joule or 109677 centimeter inverse. Let us see the Lyman series. So in case of the Lyman series, electron comes back from n2 to n1 equals to 1. So higher energy levels of our 1 ole ghuri ahibo, then we get the Lyman series. A series of lines can be obtained, each corresponds to a particular coming back of electron from a higher energy level to n equals to 1. Now so ekdom usorar kontu energy hobo Lyman line. So the nearest the first Lyman line, this is 1 or ekebare usor energy level to ki, what is the nearest energy level to n equals to 1? So the nearest energy level to n equals to 1 is n equals to 2. That means the transition corresponding to n2 equals to 2 to n1 equals to 1, this is called first Lyman line. This is the first Lyman line, and the delta E for the first Lyman line will be 21.8 into 10 to the power minus 18 into 1 by n1 square, that is 1 square, minus 1 by n2 square, that is 2 square joule. So this is the energy of the first Lyman line. So what you do is, what is the wavelength for the first Lyman line? You do it and send homework. Okay. So this is for the first Lyman line. Now if I consider the second Lyman line, so first Lyman line, that means nearest energy to n equals to 1. So first Lyman line n equals to 2 to n equals to 1. Second Lyman line n2 equals to 3 to N2 equals to 1. So please find the energy. N equals to 4 to N equals to 1. Okay. Again, please find the energy now. So this is delta E1. Delta E1. So this is, let us see that this is delta E2 বুলি ধৰি লম এটো এইটো আমি delta E3 বুলি ধৰি লম that means so delta E1 that means delta E1 means from 2 to 1 energy difference from 2 to 1 delta E2 from 3 to 1 so delta E1 from 2 to 1 will be less than delta E2 from 3 to 1 so 2 or 1 or major energy to 3 or 1 or major energy they come which is again less than delta E3 that is the energy difference from 4 to 1 okay it means যেটো first Lyman line hobo first Lyman line or energy to কম hobo second Lyman line or energy to বেশি hobo third Lyman line or energy to আরো বেশি hobo that means consecutive Lyman lines the energy difference increases যদি energy difference to by গৈ থাকে তেতিয়া হলে the wavelength will decrease first Lyman line of যেটো wavelength এৰি দিলে second Lyman line of energy বাহি গল that means wavelength ছুটি হৈ যাব energy is inversely proportional to wavelength যদি delta E1 is less that means wavelength will be more that means the longest wavelength in the Lyman series will be that of the first Lyman line longest wavelength why because it has least energy difference to আটাইতকৈ কম হেকাৰণে wavelength to আটাইতকৈ দীঘল হ'ব okay since wavelength is inversely proportional to energy let us see a problem now calculate the wavelength for the limiting Lyman line so you are asked to calculate the wavelength for the limiting Lyman line so what is the limiting Lyman line so limiting Lyman line is the first Lyman line prothom Lyman line to ke limiting Lyman line boli koy okay so what is the first Lyman line first Lyman line corresponds to N2 to N1 equals to 1 so where N2 is 2 so from 2 to 1 so 2 পৰা একলে গৈছে that is the limiting Lyman line so what is 1 by lambda equals to 109677 1 by N1 square minus 1 by N2 square centimeter inverse so 1 by lambda equals to 109677 so N1 is 1 N2 is 2 1 minus 1 by 4 so from this we get 1 by lambda and when we take the reciprocal of 1 by lambda we get lambda which comes out in centimeter please do this and send as homework